Hello and welcome to second part of our presentation on low power amplifiers. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. After going through this presentation, the learner will be able to calculate the gain of multi-stage amplifier, and here we will study the multi-stage, that is the RC coupled amplifier BJT based, circuit diagram operation, frequency response and applications of RC coupled amplifier. Transformer coupled and direct coupled will be covered in the next presentation. So here we go. The multi-stage amplifier, when two or more stages of amplifiers are interconnected, then it is called multi-stage amplifiers. If the interconnection is of the similar type, then it is called cascading, and if the two dissimilar types of amplifiers are interconnected, then it is called cascading. For example, if common emitter is coupled with common emitter amplifier, another one, then it is called cascading. And if common emitter amplifier first stage is coupled to common base or common collector second stage, then it is called cascading. Then what is the need of cascading? Very important. What is the need of cascading? As we know, single stage is not enough to provide the required amplification, so we require the multi-stage amplifier. And second, the impedance matching problem is there in the single stage amplifier, which cannot be obtained here between the input impedance of the amplifier to that of the source impedance, and output impedance of the amplifier to that of the load impedance. So for the multi-stage amplifier, gain is calculated, overall gain is calculated as a product of the individual gains, say AV1 into AV2 into AV3 into so on for the n stages. So in decibel, the overall gain is GV is equal to GV1 plus GV2 plus GV3, where GV is in decibel. Remember, it is in decibel. So it is calculated as 20 log AV. AV is the overall gain calculated in the first equation, and similarly overall current gain will be the product of the individual current gains, AI1 into AI2 into AI3 into n number of such AI. Overall power gain can be calculated as AV into AI, where AV is the overall voltage gain and AI is the overall current gain. So in decibel, it is 10 log AP, where AP is the overall power gain. Practically, there is a reduction in the gain obtained. Why it is happening, that we can think of for a while. Okay, so the reduction in the gain is due to the loading effect in the multi-stage amplifier. Now the types of the BJT amplifier coupling. Here we see the circuit diagram, the operation, frequency response and applications of RC coupled amplifier. First, see the types of coupling. The type of coupling, first one is the RC coupling, where resistor and capacitor are used as the coupling component. In transformer coupling, the transformer is coupling the output of one stage to the input of second stage. And direct coupling, no coupling component, directly output from one stage is coupled to the second stage or the next stage. And in impedance coupling, inductor resistors are used as the coupling component. So first, RC coupling is suitable for high frequency applications, and the signal across the RC is in each stage is coupled to through the coupling capacitor CC into the base of the next stage. Then the second, transformer coupling, provides excellent impedance matching, as the resistance of the transformer winding is very small compared to that of the RC, and ensures maximum power transfer from one stage to the next. Higher voltage gain is obtained compared with that of the RC. Then direct coupling. Direct coupling is suitable for low frequency as the coupling components are larger at low frequency. Impedance coupling. RC is replaced by inductor L, which will pass DC but block AC. So in the adjacent figure we see the different coupling schemes: RC down transformer coupling, and up corner impedance coupling, and direct coupling. RC coupled amplifiers. Here we see two single stage RC C amplifier coupled with the coupling components RC, CC and RB. The capacitors C1 and C2 are the coupling capacitors. C1 couples the input and C2 couples the output at the RC to output. So when Vin input signal is applied to the base of the first transistor, the first stage amplifies the signal and output is coupled to the base to the second through the coupling capacitor CC for further amplification, and amplified version is obtained at the RC2 of the second stage. So overall there is 360-degree phase shift. As we know, for one stage introduces 180-degree phase shift, so with 360-degree phase shift is obtained and output is in phase with the input. Frequency response. Frequency response, we see the flatter frequency response in the mid frequency range, and the frequency voltage gain reduces at lower frequency and at frequency greater than 20 kilohertz. This reduction in gain is due to the capacitive reactance of the coupling components. At low frequency, the capacitive reactance XCC will be more due to F value low, and it will permit therefore only a small part from first stage to the next stage through coupling capacitor. Moreover, the emitter bypass capacitor is not properly shunting the emitter resistance, that is because of its large reactance at low frequency. Then for the frequency greater than 20 kilohertz, the reactance due to coupling capacitance CC of the circuit becomes quite small and behaves as short circuit. So loading effect of the next stage rises, which reduces the voltage gain. Then for the frequency range 20 Hz to 20 kilohertz, the mid frequency range, which here the capacitive reactance XCC decreases with increased frequency and increases voltage gain. At the same time, lowered reactance increases loading effect of the next stage, due to which gain reduces. Thus almost cancels each other effect and maintains a constant gain in this mid frequency range. Then the advantages of RC coupled amplifiers. Most easy, and since we are making use of the resistor and capacitor, so less expensive, wider frequency response, less frequency distortion. Disadvantage, a smaller overall gain due to loading effect and poor impedance matching. Noisy, it becomes noisy with aging. And application, initial stage of public address system makes use of RC coupled amplifier in audio frequency amplifier and tape recorders, radios and TVs. Numerical on gain calculation. So here we see the three stages of multi-stage amplifier with the gain 60, 100 and 160. And so the overall gain is the product of the individual gains, 60 into 100 into 160, that comes to 964 times 0, and in dB it is 119.6 dB. Here is another numerical for practice on RC coupled amplifier, two-stage RC coupled amplifier. So what we learned in this presentation: multi-stage amplifier, how the gain is calculated, overall gain is calculated. Then we saw the coupling schemes, the 4 types of coupling scheme: RC, transformer coupling, impedance coupling, and direct coupling. And RC coupled circuit we saw, where we obtain the in phase output amplified version at the second stage collector. And frequency response, we saw the flatter frequency response for the mid frequency range 20 to 20 kilohertz, and at higher frequency the gain reduces due to the reactance of the coupling capacitance and due to the action of emitter bypass capacitor. Then we saw the advantage and disadvantage and applications of the RC coupled amplifier. That's all. Thank you very much.